can you solve this math challenge? Here's the question. Solve for the real value of n given that e raised to n plus e raised to 2n equals e raised to 3n. You can pause this video if you want to give this problem a try. Now, let's answer this question together. So our goal in this question is to solve for the real value of n. Given this equation, e raised to n plus e raised to 2n equals e raised to 3n. Now, to answer this question, we will use this identity. If we have b raised to the power of a times c, it is equivalent to b raised to a raised to the power of c, or b raised to c raised to the power of a. Therefore, e raised to 2n can be written as e raised to n raised to the power of 2. Also, e raised to 3n can be written as e raised to n raised to the power of 3. Now, why we do that? Take note that we now have same term of e raised to the power of n. So, let's use another variable to represent e raised to the power of n. Let's use x. So, let x be equal to e raised to the power of n. Therefore, all e raised to the power of n can be replaced by x. So, we have now x plus x squared equals x cubed. Now, let's set aside this x raised to e raised to n. And also take note, since x equals e raised to the power of n, x must be greater than 0, because e raised to the power of n is an exponential function. An exponential function cannot be equal to 0. So now let's continue. We have x plus x squared equals x cubed. Now rearrange some terms a little bit. This will give us 0 equals x cubed minus x squared minus x. Now let's factor out x. We have now x multiplied by x squared minus x minus 1. And since it is equal to 0, it follows that at least one of them must be equal to 0. So we can say that x equals to 0 or x squared minus x minus 1 equals to 0. And now, since x must be greater than 0 right here, therefore we can now disregard the case wherein x equals 0. This will give us x squared minus x minus 1 equals 0. And this is very familiar equation to us, because if we use quadratic formula in this equation, we get what we call the golden ratio. Therefore, the value of x given this equation, x squared minus x minus 1, simply 1 plus or minus square root of 5 over 2. And now, take note again that x must be greater than 0. So we can disregard the case wherein the value of x must be 1 minus square root of 5 over 2. This remains one real value for x. This is 1 plus square root of 5 over 2. And now, let's focus on this value, and since it is equal to x, and we know that x must be equal to e raised to n, and we want the value of n, so we can equate e raised to n equals 1 plus square root of 5 over 2. Now, to solve for the value of n, let's get the natural log on both sides. Now, take note that if we have ln of e raised to the power of a, it is equivalent to just a. Therefore, the left-hand side of our equation is simply equal to n. Therefore, the value of n in our equation, the only real value of n, must be equal to the ln of 1 plus square root of 5 over 2. Therefore, our final answer to this equation, what is the value of n in this equation, e raised to n plus e raised to 2n equals e raised to 3n, must be ln of 1 plus square root of 5 over 2. And as always, we are done.